Mic testing 1 2. Mic testing. Mic testing 1 2. Mic testing. Mic testing. Right, so we're gonna start looking at this particular tutorial whereby we're going to see how you are supposed to work out different questions to do with vectors. And at this point of time, we shall be focusing on especially how to find direction and how to find direction vectors. So one of the areas that you are going to be tested on how to work out and how to go about it is position vectors, and especially you'll be required for your case to be able to find position vectors of 2 points. Remember, vectors can be expressed as AB, can be expressed as unity vectors I and J. So that is an area that you need to know. Like for instance, here we have OA, which is 1 2, and OB, which is 4 1. Then for us to find AB, you need to realize that for you to find AB, it will be OA plus OB, which is the same as OB minus OA. So that is what you are supposed to do, or was supposed to know at that particular point. So we're going to look at different vector notations so that whenever you're going to be given a question, you can be able to work it out. So if you're new to ProfLearn YouTube channel, consider subscribing so that anytime we are going to upload more tutorials, you'll be notified. So let's dive in and get started so that we can be able to check. So another concept that you really need to understand, all you need to master, is the concept of magnitude, because you may be expected to answer a question to do with magnitude. Now in this case, let's see, if you found the position vector here, magnitude is going to be equals to, so the magnitude of this vector is going to be what? For instance, if we are given vector AB, what will be the magnitude? You are going to realize that if you're given a vector like this, AB or AI plus BJ, then it means for you to find the magnitude of this particular vector AB, magnitude is represented by this modular sign like that, then it will be A squared plus B squared, and then you find the square root for that. So ideally that's what you do. Now in this case, for instance, if we were having our position vector AB, which was 3 negative 1, then for you to find the magnitude of that vector, it's going to be square root of, that is 3 squared plus negative 1 squared. So you can see 3 squared is going to give us 9, then plus 1, that's going to be root 10. So the magnitude for this is going to be root 10. So that's exactly what you are supposed to do at that particular point. So moving further, so that we can be able to look at other concepts. In that case, all right, so the next part also we have to look at is the part whereby you are supposed to add and subtract as well as multiplication of vectors. You can be given scalar multiplication and subtraction of vectors, which are given in terms of column form. At the same time, you can be given addition, subtraction, multiplication in unit vectors. So under additional math, those are some of the areas that are quite important as far as that area is concerned. Now let's see how that is going to turn out. So you're given vector A and vector B there. Then you are supposed to find, Roman 1, you're supposed to find what? 2A plus B vector. So meaning that 2 times the value vector A and then plus 3 negative 1. So meaning that in the first one, we shall multiply 2 times 2 and then 2 times 5, which is going to give us 4 and 10. Then we shall have plus 3 negative 1, and then if we add corresponding components, so we are going to add x components and the top and the bottoms. So we shall add 4 plus 3 and 10 plus negative 1, so that we can be able to get the answer there. That is addition vectors. Of course, you may be given in unit as unit vectors. Also, it's just the same approach that you are going to use, but you're gonna add I components and j components that case. But here I want to change and give you a question to do where you are supposed to find maybe missing values. And here you can see we have column vectors, and then you're supposed to find the value of x and y. So in such kind of case, you consider x components and y components separately, so that you can be able to find the value of x and y. In this case, we shall have our value of y to be 8. Y is going to be 8 at that point. You need also to be aware on how to work out resolving vectors. That's another area that is going to be tested, how to resolve vectors. Now, if you are given a vector like that acting at an angle theta, so if this is a velocity v, then this angle, so v, and then we have this is the vertical line forming 90 degrees at this point, and then this component here is going to be v cos theta, and this component, vertical component, is going to v sin theta. So once we have this, then we can be able to say now this vector can be written as, funga yo mulango, can be written as, if v was speed, then we can be able to have a velocity vector. Can be written as a velocity vector. So that means we can say the velocity vector here is going to be v cos I plus v sin j. And we're going to see one of the question, we're going to see a question whereby you can be able to use this particular concept and see how you can be able to apply that during exam. So in this example that we are having at this point is to see how do we use that. Now we are told that a particle moving at a speed of 2 meters per second at a bearing of 120 from the origin. Now we are supposed to find the velocity vector of this particular part. So how do we find the velocity vector whenever you are given a bearing like that? So remember, bearings are usually measured from the north pole, then it means that for us to find the velocity vector for this, we are going to say that this is going to be what? That is the position, and then the bearing is basically going like that, and this is basically 120 here. But what we need to remember is that we have the horizontal components and also we have the vertical components. But the horizontal components, the east, vertical component is going to the south. So meaning that for us to know which angle we have, there is to be 120 minus 90. So this angle here is going to be 30 degrees. This is 30 degrees at that point. The next meaning that we need to find now the horizontal and vertical component of this particular motion. That is going to be, the speed here is basically 2 meters. No, this is 2 meters. 2 meters. No, 2 meters per second. And then if we want to find the horizontal component, that's going to be this horizontal component, 2 cos 30 I, 2 cos 30 I minus. Why are we saying minus? Because this object is moving downwards, so meaning that we're going, it's in the opposite direction to the north, so meaning that is south. When it's moving downward, we're going to say negative. To the left, we're going to say negative, but to the right is positive and upward is positive. So in that case, we're going to also find the vertical component, which is 2 sine 30, but it's negative because it's acting downwards. So that is going to be 2 sine 30 down like that. Velocity vector now is going to be, you can now crunch this into the calc. Then you saw that 2 cos 30 is going to be what? You can be able to put that into the calculator, and that is going to translate to root 3i, and this other one is going to be minus 1j, so that's going to be just minus j. Yeah. All right, so moving further so that we can be able to see, you can be able to write in position as column vectors, or you can be able to write it as unit vectors like that. Moving to the next concept that you may be tested in this particular topic, you need to understand how to work out you need to understand how to work out velocity vectors and direction vectors, velocity vectors and unit and speed. Yeah, so we can talk of velocity vector and speed. So upon discussing that, we need to understand that when you are given a speed and the direction, or the velocity, sorry, when you are given velocity vector, then it means that speed can be calculated, and velocity vector can be given as unit vector or position vector, which can be given like that. So meaning that for you to find speed, you need to work out the magnitude. You need to calculate the magnitude of the velocity vector, or in unit form or column form. So speed is going to be equals to the magnitude of a velocity vector. Okay, so which means that for us to calculate that, we are going to say this is equals to, magnitude is going to be actually a squared plus b squared. So whenever you're given a velocity vector, you need to remember that you can be able to work out a unit vector from there. Okay, so in that way, okay, so for that case, let me just that so that you can be able to talk about that. Yeah, so when we are talking about velocity vector, unit vector, yeah, so that is for instance, you are given e.g. a velocity vector as 4I minus 3j. So what are you supposed to do whenever you're given a question like that? And then you are expected to work out the velocity vector. So something that you need to remember here, whenever you are given a velocity vector for you to work out speed, you need to find the magnitude of that. You need to find the magnitude of that case. So that's why I'm saying, so that we can be able to show how you can be able to find that speed. We have a unit vector, and then we can now work out the speed of that particular particle whose unit vector is 4I minus 3j. So that means this is going to be for 16 plus 9, and that is going to translate to 25 meters per second as the speed. So given speed, you can be able to work, given velocity vectors, you can be able to work out speed like that. Next area that I want us to focus on in this case is working out question to do with unit vectors. So if you're given a unit vector, or you are given a vector as the direction, then you can be asked to work out the unit vector, right? Now, like for instance, this case here, we are told that the velocity vector when given a speed and direction. So find the unit vector. To find the unit vector or velocity vector when given, how to find the velocity vector when you're given speed and direction. So the first thing that you're going to do, point number one or step number one, when you're given such, the first step is to find the unit vector of the direction. So, and remember, for you to find the unit vector of the direction, it will be the direction vector divided by the magnitude of that particular direction vector. Then the second step is taking that unit vector that you have gotten, you multiply it to the speed that you are given. So that's what you are supposed to do whenever you are finding the velocity vector when given speed and direction. From the previous section, we have looked at how you can be able to find velocity vector when you are given how to find speed when you are given the velocity vector. And we have said when you are given a velocity vector, to find speed you need to find the magnitude of that particular velocity vector. But if you are given a direction and you are given the speed, you can be able to find the velocity vector by finding first the unit vector and then take that unit vector of the direction, multiply it to the speed. Now I want you to take you through how you can be able to work out a question like this one. And we are told that a particle moves at 10 meters per second in the direction of. So meaning that this part that we have here is basically the direction vector. So if you are given a direction vector like that, then you can be able to go ahead and work out the velocity vector. And that is exactly what we have said here, that we can be able to work it out. Let's say we have said To find the velocity vector, when you are given speed and direction, first you need to find the unit vector. And to find the unit vector is direction of the vector, direction vector, divide by the magnitude of that direction vector, which is a over magnitude of a. Then how do we go about it? Let's see now the example that can make us understand basically what we are trying to say here. Velocity vector is basically speed times the unit direction vector times the unit direction vector. So the next thing that we're going to do here now is to work out an example that can make us understand how we can be able to go about such kind of questions. Now, for instance, here we are given a particle, and this particular particle is moving at 10 meters per second in the direction of. You can be told it's moving parallel to, or you can be told it's moving in the direction of. So once you have that particular direction, then you can be able to use this as the direction. So meaning that this one, you are going to find the unit direction vector, and then you multiply it to the speed that we have. So this unit direction vector, if we can write it in column form, the magnitude is going to be what? It's going to be square root of 4 squared minus 3 squared, and then that is going to translate to square root of 25, and that's going to be 5. So the magnitude is 5, then meaning that unit vector is going to be written as, unit vector is going to be 1 over 5. We can say unit vector, unit direction vector, 1 over 5 times, okay, we can just write it like that's the formula, of course. Then we can be able to divide every term there by 5, or you can write this as 1 over 5 multiplied by 1 over 5 from outside. So that is just meaning that every element that is inside is divided by 5. So this, we can just leave it that way, or you can even open all the bracket, but I like to leave it that way outside like this, because we're going to multiply with the speed. Now velocity is going to be the speed 10, the speed, remember, was 10 times 1 over 5 into 4 negative 3. Then 5 can cancel, and with 10 to have 2, and then we shall have this. Then 2 times 4 will be 8, and negative 6, like that. Now, since we were given direction vector as unit vectors, we can decide and write our answer in unit vectors. 8j minus 6, 8i minus 6j, like that. That is now what we call our direction vector, our velocity vector in meters per second. All right, so once we've done that, let's see now. Once we have obtained that, finding position vectors is also another important area that you need to understand. What you need to understand is that the new position vectors, the new position vector is equal to initial position plus velocity vector times time taken. So for instance, if a particle is traveling at 20 meters per second in the direction of this, find the velocity vector. Already we have worked out a question like that, but now I want to check how do you find a new position after some time. So in that case, for you to find the velocity vector, this is the second example, you can be able to find the magnitude of this velocity vector here. We'll find the magnitude of this by saying 6 squared plus 8 squared is equals to, then you find square root, you're gonna get 10. Then unit direction vector of this is going to be 1 over 10 into 8, 6. Then velocity vector will be speed times unit direction vector. So I usually like leaving it like this, so that whenever you are going to multiply with the speed, you can see this and this can cancel out, and then you are going to remain with 2 times 6, which is 12i, and then 2 times 8, which is going to be 16, and that is the velocity vector. Now, if the initial position of P was 4 minus 3, find the position vector of Q after 5 seconds. So remember, we have the velocity vector, then, and we also have the initial position vector, then final new position vector is going to be what? Initial position vector plus velocity vector times time, and time is 5 seconds. So that is why we are going to use initial position vector 4 minus 3 plus 12 16, which was the velocity vector. Velocity vector, we got it as got it as 12 16, which can be written in column form like that, times 5. So that's going to be 5 times 12, which is 60, 5 times 16, which is 80. Then if you work it out, you are going to get your answer 64.77 as the new position, and you can write it in unit vector like that. Something else you need to remember is that object is at its initial position when time is 0. So if you are told, you are given a position vector in terms of t, and they're asking you to find the initial position vector, you are going to take that as time t is 0, right? Then we have another concept that you have to remember, that object meet or collide if their position vectors are equal or they are at 0 distance between them. So you may be given question like that. So this is a question that you can now attempt. You can be able to attempt this so that you can be able to see whether you can be able to solve question and problems involving position vectors. Attempt it and then pause the video so that you can be able to see the solution, how I've worked it out.